All right, how's everybody doing out there today? This is Mr. Muscarella coming at you, and in this lesson, we're going to take a look at improper integrals. Now let's just review real quickly. There are two types of discontinuity. The first type is removable, and that's where you want to think about factors canceling out where there's a hole in the graph. The second type is a non-removable discontinuity, which is more or less a jump discontinuity or the infinite discontinuity. Now for improper integrals can be evaluated over an open interval rather than a closed one, and an integral is improper either its integrand becomes infinite at one or more points in the interval of integration, or one or both of the limits of integration is infinite. So what that basically says real quickly for that second piece is either right down here you're going to have negative infinity, or maybe in the top piece your limit of integration is going to be infinity. So to integrate an improper integral, you're going to just evaluate the integral for a constant and then take the limit of the resulting integral as that constant approaches the limit that we're questioning here. So if the limit does exist, we're going to say converges, and it'll end up being a number. If, however, the limit does not exist, then the limit diverges, and the integral cannot be evaluated there. So these are going to be a couple points to keep in mind as we look at evaluating improper integrals. All right, so now let's go ahead and take a look at our first example. State why the integral is improper and determine if it's divergence or convergence. Evaluate the integral if it converges. So what we're going to do is take a look here at our limits of integration. We're going from 3 to 4 for our limits of integration, which, if you look here at the bottom limit of integration, we plug that in, that's 0, which is bad in our denominator, because when you end up with 0 in the denominator, that's going to give you an infinite discontinuity at x equals 3. Now if we were to take a look at this graphically, so I'm going to just kind of do a little quick sketch of it. Say 3's here and then 4's here. Now we're going between 3 and 4. So we know we've got a vertical asymptote right there at 3, and since we're going between 3 and 4, 4 is to the right of 3. So I'm going to pick a number between 3 and 4, like say maybe 3.5. If I plug 3.5 in here, 3.5 minus 3 to the 3/2 power, that'll give me something positive. So 1 divided by something positive is still going to be something positive. So that would be somewhere around here. Now if I put 4 in, 4 take away 3 is 1. And 1 to the 3/2 is just 1, so 1 divided by 1 is 1. So that would end up giving me this piece right here. So I can kind of tell a little bit from those 2 points that my graph is going to have a sketch that kind of goes like this. All right, so I want all of this area that's going to be here between 3 and 4 for this particular curve. Now, after we look at that, we're going to go ahead and we're going to evaluate it using the limit process. We're going to evaluate the limit of our integral, and we're going to replace the number 3. The number 3 is going to be replaced by an a. And so when we do that, we're going to replace the limit as a approaches 3. And a little plus sign is the right side, and that's because we're taking the limit between 3 and 4. So we want all of the area from the right of 3 all the way up to 4. So that's the first thing that we're going to do, is we're going to rewrite that integral using a limit right out in front of it. Now the next thing that we're going to do, pretty straightforward evaluating these pieces, you're just going to go ahead and evaluate that integral part, but we're still going to have the limit piece right out in front, and we're going to notice right here in the denominator, or in the bottom right here, your limit of integration is still going to be a. All right, so we're going to go ahead and just go one step at a time. We're going to plug in 4. Now, of course, -2 if we do 4 minus 3. So we're going to have this limb still hanging out here in front. It's not just going to go away. This is still going to be here. So when you're writing it, make sure that you still write that piece of it, because it doesn't just disappear and go away. So we're going to evaluate our limit at 4 and a. And then after we do that, we're going to end up with just this little piece here. When you clean up your algebra, we kind of rewrite it, because you can do that if you want to write that so it's in the denominator like so. But if you plug in 3 right here, 3 in the denominator is going to, this piece right here, that's going to go to 0. All right, so you're going to have 2 over 0, and of course that's bad. We don't like that in math. So since that's what happens, then your limit is going to approach infinity, which means it's going to be divergent. You're not going to be able to come up with an answer for this type of problem because you end up dividing by 0, which is not possible. So therefore, our limit is going to diverge.